वेलकम। आज की इस वीडियो में हम हमारी समाकलन गणित की सीरीज को आगे बढ़ाते हुए आज हम देखने वाले हैं बीटा फंक्शन एंड उसकी कुछ प्रॉपर्टीज। तो सबसे पहले देखते हैं डेफिनेशन कि बीटा फंक्शन होता क्या है। ओके, तो कोई भी एक फंक्शन है, बीटा फंक्शन को हम डिनोट करते हैं बी एम एन से। ओके, इंटीग्रेशन लिमिट 0 to 1 सॉरी 0 to 1 एक्स टू द पावर m minus 1 1 minus x to the power n minus 1 dot dx where m and n both are positive integers. So any function in this form we call it as a beta function. इसकी जरूरत हमें पड़ती है जब भी हम समाकलन गणित में कुछ प्रॉब्लम्स को सोल्व करते हैं, तो हमें इस तरह की प्रॉब्लम मिलती है तो हम उसे डायरेक्टली सोल्व कर सकते हैं। ओके, तो इसे आयलर का फर्स्ट इंटीग्रल भी कहते हैं। ओके, इज नोन एज आयलर्स फर्स्ट इंटीग्रल। ओके, अब देखते हैं इसकी कुछ प्रॉपर्टीज। जैसे मेनली आज हम इसकी तीन प्रॉपर्टीज देखेंगे। दैट इज फर्स्ट, बी एम एन इक्वल होता है बी एन एन के। वी विल प्रूव ऑल द प्रॉपर्टीज। बी एम एन इक्वल होता है इंटीग्रेशन 0 to infinite x to the power m plus 1 sorry m minus 1 might take m minus 1 and 1 plus x to the power m plus n dot dx. And the third property is that b m n equal 0 to pi by 2 twice of sin 2m minus 1 theta cos 2n minus 1 theta dot d theta. Okay, so this all three properties we will prove one by one. So first we will prove b m n इक्वल होता है b n n. ओके, इसे प्रूव करने के लिए हम जो हमारी बीटा फंक्शन की इक्वेशन है, सपोज दिस इज इक्वेशन फर्स्ट, our beta function. Okay, this is our beta function. If we say this equation 1, so इसमें अगर हम x की जगह 1 plus y रखें, सॉरी 1 minus y रखें, तो हमें क्या मिलेगा, dx इक्वल माइनस dy. ओके, तो एम एन है ना, तो x की जगह हम इक्वेशन फर्स्ट में देते और बीटा फंक्शन, उसमें अगर हम y 1 minus y रखें तो हमें मिलेगा 1 dx इक्वल माइनस dy. एंड इफ वी चेंज द लिमिट, तो x की जगह अगर हम 0 रखें तो y की जगह मिलेगा 1, एंड y की जगह x की जगह अगर हम 1 रखें अपर लिमिट, तो हमें क्या मिलेगा 1 सॉरी 0 है ना. So we get dx. Now what is the beta function? X to the power n minus 1. Here x is 1 minus y. So 1 minus y to the power n minus 1 dot 1 minus 1 minus y, that is y n minus 1, and dx की जगह हम क्या रखें, माइनस dy. ठीक है, तो अगर हम माइनस साइन को रिमूव करें तो हम इस जो लिमिट है इसे ऑल्टर कर सकते हैं. ओके, तो सिंपली यू कैन राइट बी एम एन इक्वल होता है 0 to 1 1 minus y m minus 1 and y to the power n minus 1 dot dy. ओके, और यही हमारा बीटा फंक्शन है. ठीक है, इसे सब रीअरेंज कर लेते हैं. 0 to 1 y to the power n minus 1 dot 1 minus y to the power n minus 1 and dy. See this carefully, this is nothing but the beta function. Okay, so we can write it as, if we suppose change it in the x, because our main beta function is in the form as x to the power n minus 1 1 minus x to the power n minus 1 dot dx. ओके, हम x की जगह y रख सकते हैं, y की जगह x रख सकते हैं. इफ वी put the same, the integral will not be changed, will be same 100%, because it is basic property of an integration function or integral function. Okay, so dx will be dy simply, and limit will be same because both values are same. So this is our beta function, but only difference is n and m has been interchanged, because in our standard beta function x to the power m minus 1, but here n minus 1, so we can write this as m n. Okay, and what was the in the left hand side, beta mn. So we have proved the first property. Okay, now we will see the second property. What was that? We have to prove beta mn equal होता है इंटीग्रेशन 0 to infinite x to the power n minus 1 upon 1 plus x to the power m plus n dot dx. Okay, now let's put y upon 1 plus y in the place of x in equation number first. That is our beta function. Okay, so if you put the y upon 1 plus y at the place of x, we will change the limit accordingly. Let's first change the limit. Okay, no problem. So if we put 0 at the place of x, we will get y equals 0. Okay, and if you put x equal 1, we will get y value infinite. Okay, now what will be dx? Dx nothing but the, if we differentiate this function, we will get minus y, that is 1 upon 1 plus y whole square dy. Okay, now put this uh, answer, sorry, now put this in the equation number 1. Okay, so what will we get? Beta mn equal integration limit 0 to infinite. And now what we have put the at the place of x, 1 y upon 1 plus y. Okay. So y upon 1 plus y to the power m minus 1 into 1 minus y upon 1 plus y to the power n minus 1. And what is the value of dx now? 1 upon 1 plus y square, y का whole square, sorry, dy. Okay, now we have to simplify this. 0 to infinite y to the power m minus 1 upon 1 plus y to the power m minus 1. Now here we will only remove 1 upon 1 plus y to the power n minus 1, and here 1 plus y to the power whole y and dy. Okay, 0 to infinite. Now y to the power n minus 1 in the numerator, and now in the denominator, if you solve this, here we had the base same, so here minus 1 minus 1. Okay, minus 2, that minus 2 will cancel this power, so we will get only 1 plus y to the power here m and n. Okay, so m plus n and dy. Now this is the required property. Okay, this was the same property as we have to we are supposed to prove. Okay, now we have to change only x at the place of y. Okay, so we have proved the our second property. Now we will prove the third one, that was, and the third one is very easy property. Beta mn equal price of 0 to pi by 2 sine 2m minus 1 theta dot cos 2n minus 1 theta d theta. Okay, so to prove this, we have to put x equal sine square theta at the place of x, है ना? Then we can get dx equal to 2 sin theta cos theta and d theta. Sorry. Now, and if we put the change the limit at the place of x as the lower limit, what is the lower limit of beta function? Is 0. So x equals 0, then what will get? The value of theta equal to 0. Now at the place of upper limit, that is x equals 1, we will get here pi by 2. Okay, this is a sine function. So now put this all the results in the equation number first. So beta mn, we will get integration limit 0 to pi by 2. Now x to the power m minus 1, and what is x here? Sine square theta is x, and what is 1 minus sine square theta? That is n minus 1 and dot dx, and what is dx? Nothing but 2 sin theta cos theta d theta. Theta d theta. Okay, now 0 to pi by 2 sine 2m minus 2 theta. What is called 1 minus sine square, is cos square theta. Cos 2m minus 2 theta. Okay, cos square theta and the n minus 1 pi will be distributed to this whole term. Now 2 sin theta cos theta d theta. Now this is only one power, this is also one power. Okay, so now what we can do is we can cancel out this minus power. So what will we get? Sin 2m minus only 1. Okay, because it is plus 1 power, it is minus 2, so we will get minus 1 theta dot cos 2n, sorry, this is not n, m, this is n, b to n. Okay, so 2n minus 1 theta 2 d theta. Okay, now because this is constant, we can out this from the integration. I by sin 2m minus 1 theta dot cos 2n minus 1 theta, and this was the our required property that we have to prove. Okay, we have proved this property. Now in the next video we will see the gamma function and the relation between beta and gamma function. So until then, thank you. We will meet in the next video. Thank you. समाकलन गणित की सीरीज को आगे बढ़ाते हुए आज देखने वाले हैं गामा फंक्शन एंड उसकी कुछ प्रॉपर्टीज। कल हमने देखा था बीटा फंक्शन एंड उसकी कुछ प्रॉपर्टीज। ठीक है, तो शुरू करते हैं गामा फंक्शन। व्हाट इज गामा फंक्शन? So any function in the form of this integral 0 to e to the power minus x to the power n minus 1 dot dx, it is called gamma function. It is denoted by gamma n. Okay, this is symbol of gamma function where n belongs to natural number. Now it is also called Euler's second integral, as known as Euler's second integral. Now, do you know the Euler's first integral? We have seen in the last class, that is beta function. Okay, now we will see recurrence formula for gamma function. Recurrence formula for gamma function. What is recurrence formula? Nothing but if we have the value of n, we will deduct the value of n plus 1, n plus 2, and so on. Okay, and we will generalize it. It is called recurrence formula. Okay, so now we will find the value of gamma n plus 1 first. So we will rewrite the upper gamma function. What is our gamma function? Gamma n nothing but 0 to infinite e to the power minus x to the power n minus 1 dot dx, where n belongs to natural number. Okay, so I will put n plus 1 in the place of n. What will I get? 0 to infinite e to the power minus x to the power n plus 1 minus 1, that is n dot dx. Okay, now we will apply integration by parts. So we will get x to the power n e to the power minus x n minus 1, that is, we can write this out of this box. Now we will apply the limits 0 to infinite minus integration 0 to infinite differentiation of first function, that is n x to the power minus 1, integration of second function e to the power minus x n minus 1 dot dx. Okay, you know this formula because you have read it earlier in 12th class. So now we will apply this limit. So what we will get, this is infinite, so we will get, if I apply the minus infinite limit on this function, we will get 0 because e is greater than 0, and if e to the power minus n, that means 1 upon e to the power infinite. Now e to the power infinite will be 0 because e is greater than 0, so this whole function will be 0. Okay, now if I put the lower limit on this function, we will get now this 0, because if I put 0 on the place of x, we will get 0. Okay, minus, I can write out of this box this integral infinite. Now this minus and this minus will cancel out this, so I can write plus. Now x to the power n minus 1 e to the power minus x dot dx. Now see carefully, this is our nothing but gamma function. Okay, so I can write n plus 1 gamma equal to n, and I can write root infinite e to the power minus x to the power n minus 1 dot dx, and this is nothing but the gamma function. So I can write here what we get, n plus 1 will be n gamma n. So this is our recurrence formula. Now where n greater than 0. Now we will see one result. After that we will generalize this formula. Okay, so first see we will prove a result, that is gamma n plus 1 is equal n factorial. How we will prove this very result with the help of this formula. So suppose first I put n equal 1, okay, in the gamma function. So what was gamma function? 0 to infinite e to the power minus x to the power n minus 1 dot dx. Okay, so if I put 1, what will I get? 0 to infinite e to the power minus 1, sorry, minus x to the power 1 minus 1, that is 0, and simply remove it because it will be 1. Now dx. Now after integrating this function, what we will get? Minus e to the power minus x integration 0 to infinite, and this value will becomes minus minus infinite, that is 0, 0 minus 1. Okay, so what will we get? 1. So we can say that the gamma 1 equal 1. Okay, suppose this is equation 1. So if we now we will find the value of gamma 2. Okay, so I can write 2 as 1 plus 1. Okay, so here if I use this equation that we have proved earlier, this equation, okay, so I can write the value of n as 1, then we will get n plus 1, that is 1 plus 1. Okay, so suppose n plus 1 equal n gamma n, we have proved it earlier. Okay, so I put, suppose this equation second, so I will put n equal 1 in equation second. What will I get? N equal 1, so I will get the value of 2 equal 1, that is 1 gamma 1. And what is gamma 1? That is 1. So I can write it as 1. Now if I will write n equal 2 in this very formula, so I will get the value of gamma 3 equal to 2 gamma 2, that will be 2 dot 1, because the value of gamma 2 is 1. Okay, now if I put n equal 3, what will I get? The value of gamma 4 will be 3 gamma 3, that nothing but 3 into, what is gamma 3? 2 into 1, 2 into 1. And if I write n equal 4, I will get the value of gamma 5 will be 4 gamma 4, that is 4 into gamma 4. What is gamma 4? 3 into 2 into 1. I am not solving it because this is our recurrence formula, and you can easily see that this is in pattern. Now we will generalize these results. Okay, so gamma n plus 1, and what will be the answer? Let's, we will observe here. If I put gamma, sorry, n equal 1 in this uh, equation, that is equation number second, what I get? N plus 1. Okay, that is 1 plus 1. If I put n equal 1, 1 plus 1, that is gamma 2. Now gamma 2, that is 1 gamma 1 because of this result. Okay, now we will find the factorial 1. As the we put n equal 2 in this equation, that gamma 3, what will you get? Gamma 3 as 2 factorial. This is nothing but 2 factorial. This is nothing but 3 factorial. Okay, this is nothing but 4 factorial. Then we can deduct that gamma 2 is 1 factorial, gamma 3 is 2 factorial, gamma 4 is 3 factorial, and gamma 5 is 4 factorial. That gamma n plus 1 will be n factorial. Okay, this is simple observation. Now we will move ahead. Now we will prove a standard integral. After that we will call it a day. Okay, so we will see now standard integral. What is standard integral? First see, we will prove that 0 to infinite e to the power minus ax x to the power n minus 1 equal gamma n upon a to the power n. Okay, we will prove this formula. It is very simple formula because we will prove it using the definition of gamma function. What is definition of gamma function? Nothing but 0 to infinite e to the power minus x x to the power n minus 1 dx, where n belongs to n. We will put ax, no, sorry, any variable, suppose ay at the place of x. So what will you get at the place of dx? A dy. Okay, let's put it in gamma function. So gamma n will be 0 to infinite. Limit will be same because a is a constant. Okay, if I put 0 at the place of x, I will get the value of pi as 0. And if I put infinite, I will also get the value of pi as infinite. Okay, so limit will be no changed. We will only change the variable. So now what I write at the place of x? Ay. Okay, dot ay to the power n minus 1 dot a dy. Okay, now a to the power n minus 1 integration 0 to infinite e to the power minus ay y to the power n minus 1 dot a dy, है ना? So I can, let's, we will solve it in the next step. A dy. Now we have one power of a and here n minus 1, so I can write it simply n 0 to infinite e to the power minus ay dot y to the power n minus 1 dot dy. So here left hand side we have the gamma n, so I can write gamma n upon a to the power n equal 0 to infinite e to the power minus ay y to the power n minus 1 dot dy. We have proved this very formula. We can change this variable to x because if I write x equal y in this formula, the result will be same. It is very basic property of integration. So we have proved this formula so far. Now we will see in the next video the relation between gamma and beta function and also some other properties of beta and gamma function together. So until then, see you. Thank you. हम हमारी समाकलन गणित की सीरीज को आगे बढ़ाते हुए देखने वाले हैं रिलेशन बिटवीन बीटा एंड गामा फंक्शन। हम पिछली वीडियोस में बीटा फंक्शन गामा फंक्शन को समझ चुके हैं, उसकी कुछ प्रॉपर्टीज भी देख चुके हैं। ठीक है, तो आज हम देखते हैं रिलेशन बिटवीन बीटा एंड गामा फंक्शन। उससे पहले देख लेते हैं बीटा एंड गामा फंक्शन होते क्या है। तो बीटा फंक्शन नथिंग बट 0 to infinite, sorry 0 to 1 or infinite, x to the power m minus 1 minus x to the power n minus 1 dx, where m and n greater than 0. This is our beta function. And what is gamma function? Gamma n equal 0 to infinite e to the power minus x to the power n minus 1 dot dx, where n belongs to natural number. This is our gamma function. Okay. Now we will see the relation between beta and gamma function. So let's write the relation between beta and gamma function. बीटा फंक्शन में क्या रिलेशन होता है? गामा m इंटू गामा n अपन गामा m प्लस n. ओके, तो बीटा एंड गामा फंक्शन में ये रिलेशन होता है, इसे हम प्रूव करने वाले हैं। ओके, तो इस रिजल्ट को हम प्रूव करने के लिए एक स्टैंडर्ड इंटीग्रल का यूज करेंगे, जिसे हम गामा फंक्शन की डेफिनेशन के साथ ही देख चुके हैं और प्रूव भी कर चुके हैं। तो अगर आपको इसका प्रूव चाहिए तो आप देख सकते हैं, इसे हम गामा फंक्शन से डिराइव करते हैं। ओके, so it is nothing but a derivation of gamma function. Okay, what is standard integral? Nothing but a derivative of gamma function. So it is standard integral gamma n upon a to the power n 0 to infinite e to the power minus x to the power n minus 1 dot dx. Okay, this is our standard integral. Let's rewrite it. So I can write it gamma n a to the power n 0 to infinite e to the power minus x to the power n minus 1 dot dx. Okay, this is our nothing but the standard integral. Now we will multiply both the side with e to the power minus a and a to the power m minus 1. Okay, so what will we get? Gamma n into e to the power minus a to the power m minus 1 will be equal to a to the power n 0 to infinite e to the power minus a to the power m minus 1, and what we have in the integration e to the power minus x to the power n minus 1 dot dx. Okay, so this is constant because this does not contain any variable that is x. Okay, so we can write it out. So gamma n e to the power minus a to the power n minus 1 equal a to the power n plus, and this will be adding, so we can add because the base is same. So a m plus minus 1, and okay, integration 0 to infinite. Now we can write it e to the power minus a 1 plus x. Okay, now the base is same, and that's it, x to the power n minus 1 dot dx. Now we will integrate both the sides with respect to a under the limit 0 to infinite. Okay, so by integrating both the sides with respect to a under the limit 0 to infinite. Okay, so let's integrate 0 to infinite gamma n e to the minus a to the power n minus 1 dot dx. Okay, here sorry, this space will be less, so I will write it as 0 to infinite a to the power n plus n minus 1 dot 0 to infinite e to the power minus a 1 plus x to the power n minus 1 dot dx and dx. Okay, so I can write this gamma n because n is constant 0 to infinite e to the power minus a to the power n minus 1 dot dx. Let's first solve the integration with respect to a. So we will write the value of uh, independent of a out of this sign x to the power n minus 1. Okay, this is the only value that is independent of a. We can write it out of this sign because we are integrating with respect to a first. Now limit will be same, so there will be no question of dual integration here. Okay, so simply here 0 to infinite a to the power m plus n minus 1 and e to the power minus a 1 plus x dot dA dx. Okay, now I will assume that minus minus not minus a 1 plus x will be as y, let's say. So we can write this dA equal be y upon 1 plus x dot not y, only dy because it is only y. So it is okay. Now limit will not be changed because when the value of a is 0, y will be also be 0. Okay, and if a is infinite, so y will also be infinite. So let's put these results in our equation. So gamma n 0 to infinite e to the power minus what is here a to the power n minus 1 dot dA will be integration 0 to infinite x to the power n minus 1 dot 0 to infinite, limit will be same. Now we have changed the value of a in the form of y, so we can write what is the value of a, y upon 1 plus x. So I can write here y upon 1 plus x to the power m plus n minus 1. Okay, now the value of e to the power minus y, e to the power minus y because we have changed this value as y. And now what is the value of dA? Will be dy upon 1 plus x and into dx. Sorry, into dx. Now I am not writing this. I will write this in the next step. So 0 to infinite here x to the power n minus 1. I can put this value out of here because this is independent of variable that is y. So 1 plus x. Now what we have in the integration 0 to infinite. This is also independent of y. We can write it as here is 1 power and here is m plus n minus 1. That will be m plus n. Now what we will get under the sign of integration y to the m plus n minus 1 and here e to the power minus y dy. Okay, so and that is be dx. Now see, because with respect to x, this whole function is constant because it does not contain any variable that is y x, sorry, you know. So we can write it out of this integration sign. So let's write it as integration 0 to infinite x to the power n minus 1 1 plus x to the power m plus n dot dx into okay 0 to infinite y to the power m plus n minus 1 e to the power minus y dy. Okay, I hope you understood because it is constant for x. Okay, because it does not contain any variable that is x here, and in this integrated step the variable is y. Okay, and this term does not contain any y, so this will be constant for the purpose of dy. I hope you know the basic principles of integration. So now let's see, when we saw the properties of beta function, we also show a result beta mn equal to 0 to infinite x to the power of n minus 1, sorry, m minus 1, write it x to the power m minus 1 upon 1 plus x to the power m plus n. Okay, where m and n less than 0. So we can apply this property here. Okay, the only difference is that here m and here is n. So by the properties of this function we can write it as beta mn. Okay, because this is mn, we can write it nm. The only difference is m and n, otherwise all is same. Now okay, and what is this? See this carefully. This is nothing but the gamma function in the form of m plus n. Because in gamma function, what is the property of gamma function? Gamma n, let's change the color. Gamma n equal integration 0 to infinite e to the power minus x, okay, or x to the power n minus 1, that is dx. Now compare this with this formula. What will you get? The only difference is that we have m plus n at the place of n. So if this is gamma n, this will be gamma n plus n. Simple. This will be gamma n plus n. And here, what we have in the left side, gamma n into this property. Let's change this property also. So now, what is this? See this. This is also a form of gamma function. How? This will be this. The variable is a. This does not uh, have any effect because we have this function as gamma n. Compare this with definition. What is gamma n? 0 to infinite e to the power minus x to the power n minus 1. Okay, so it is e to the power minus a because variable is x here, so here is now the variable of a here, so here will be a, and a to the power m minus 1. Okay, so here n and here m, so we can write it as gamma m. I hope you understood. Let's move. So now what we get gamma m, and what we get is gamma m. Okay, gamma m is the here remaining here, and this value will be gamma m. तो हमें क्या मिला यहाँ पर गामा n into gamma m equal bmn into gamma n plus we can write is gamma beta m n. So we have also, let's write first gamma n into m upon gamma m plus n. Okay, how, why we write gamma, sorry, beta nm equal beta nm? Because
we know the property of beta function that beta mn equal beta nm. We have seen this property while we were discussing our beta function, so we can apply this property here. So what we will get, that beta mn will be equal to beta nm, and we can rewrite it as beta mn equal to gamma m into gamma n upon gamma m plus n, and this is our required relation between beta and gamma function. So we have proved the relation between beta and gamma function with using the standard integral. We use first standard integral, that was derivative from gamma function, and also the definition of beta function, and with the help of these properties we have proved the beta and gamma function. So thank you, we will meet in the next video. Until then, thank you. इस वीडियो में हम देखने वाले हैं स्टैंडर्ड इंटीग्रल, जो कि एक गामा फंक्शन का वेरिएंट होता है.
what is standard integral? First, we will prove that 0 to infinite e to the power minus ax x to the power n minus 1 equal gamma n upon a to the power n. Okay, we will prove this formula. It is very simple formula because we will prove it using the definition of gamma function. What is definition of gamma function? Nothing but 0 to infinite e to the power minus x to the power n minus 1 dx, where n belongs to n. We will put ax, no, sorry, any variable, suppose ay, at the place of x. So what will you get at the place of dx? A dy. Okay, let's put it in gamma function. So gamma n will be 0 to infinite. Limit will be same because a is a constant. Okay, if I put 0 at the place of x, I will get the value of pi as 0. And if I put infinite, I will also get the value of pi as infinite. Okay, so limit will be not changed. We will only change the variable. So now what I write at the place of x? Ay. Okay, dot ay to the power n minus 1 dot a dy. Okay, now a to the power n minus 1 integration 0 to infinite e to the power minus ay y to the power n minus 1 dot a dy, है ना? So I can, we will solve it in the next step. A dy. Now we have one power of a and here n minus 1, so I can write it simply n 0 to infinite e to the power minus ay dot y to the power n minus 1 dot dy. So here left hand side we have the gamma n, so I can write gamma n upon a to the power n equal 0 to infinite e to the power minus ay y to the power n minus 1 dot dy. We have proved this very formula. We can change this variable to x because if I write x equal y in this formula, the result will be same. It is very basic property of integration. So we have proved this formula so far. Now we will see in the next video the relation between gamma and beta function and also some other properties of beta and gamma function together. So until then, see you. Thank you. वेलकम। आज की इस वीडियो में हम देखने वाले हैं गामा फॉर्मूला। हम पिछली वीडियोस में बीटा एंड गामा फंक्शन की कुछ प्रॉपर्टी देख चुके हैं, बीटा एंड गामा फंक्शन में रिलेशन देख चुके हैं। तो आज हम देखने वाले हैं गामा फॉर्मूला। सबसे पहले देखते हैं ये होता क्या है। ओके, तो इट इज एन इंटीग्रल 0 टू पाई बाय 2 sin to the power m theta cos to the power n theta d theta is equal to gamma m plus 1 by 2 gamma n plus 1 by 2 upon 2 gamma m plus n plus 2 by 2. Okay, it is our gamma formula. Now we will prove this. This is very simple that we will prove it using the relation between beta and gamma function. Okay, so what is the relation between beta and gamma function? Beta mn equal gamma m into gamma n upon gamma m plus n. Okay, we have seen this proof also. Now we will use the property of beta function in this relation. So we can write this rise of 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2n minus 1 theta dot d theta will be equal to gamma m to gamma n upon gamma m plus n. Now we will substitute m as m plus 1 by 2 and n as n plus 1 by 2 in this equation. Okay, so what we will get? We will get rise of 0 to pi by 2 sin to the power the value of that is m plus 1 minus 1, that is m, and cos to the power n. Okay, it is theta dot d theta, and here we will get m plus 1 by 2 n plus 1 by 2 upon m plus 1 by 2 plus n plus 1 by 2. Now we will rearrange this. So 0 to pi by 2 sin to the power m theta cos to the power n theta d theta is equal to gamma m plus 1 by 2 gamma n plus 1 by 2 upon, we can write it as m plus n plus 2 upon 2. Okay, now we will further rearrange it. So we can write it gamma integration 0 to pi by 2 sin m theta cos n theta d theta will be equal to m plus 1 by 2 gamma n plus 1 by 2 upon 2 gamma m plus n plus 2 by 2, and this is our gamma formula. Okay, I hope you understand. Now we will further see in the next videos like some properties of beta and gamma function and also the Legendre's duplication formula. So until then, thank you. वेलकम। आज की इस क्लास में हम एक रिजल्ट प्रूव करने वाले हैं, दैट इज द वैल्यू ऑफ गामा 1 by 2 इक्वल रूट पाई। ओके, ये बेसिकली एक कोरोलरी है बीटा एंड गामा फंक्शन के बीच में जो रिलेशन होता है उसकी। ओके, तो कोरोलरी ऑफ रिलेशन बिटवीन बीटा एंड गामा फंक्शन। सो हमने जब देखा था बीटा एंड गामा फंक्शन के बीच में रिलेशन, दैट इज बीटा एम एन इक्वल गामा एम इंटू गामा एन अपॉन गामा एम प्लस एन। तो इस रिजल्ट को प्रूव करके हम जो है जो हमारा रिक्वायर्ड रिजल्ट है, दैट इज द वैल्यू ऑफ गामा 1 by 2 विल बी इक्वल टू पाई बाई 2, सॉरी रूट पाई ना। तो ये प्रूव करने वाले हम। तो सबसे पहले सपोज इक्वेशन बने, तो इस इक्वेशन वन को हम जो इसमें एम एन एन है उन्हें 1 by 2 से सब्सटीट्यूट करेंगे। तो लेट एम एन एन इक्वल टू 1 by 2। ओके, देन व्हाट विल बी गेट, सॉरी आई विल राइट हियर बीटा 1 by 2 comma 1 by 2. Okay, because m and n both are equal to 1 by 2. Now what we will get? 1 by 2 into 1 by 2 upon gamma 1 by 2 plus 1 by 2. Now we can simplify this as 1 by 2 comma 1 by 2 will be equal gamma 1 by 2 whole square upon gamma 1. Okay, this is question number 2. Now we will use a relation, that is the definition of beta function, and we saw three forms of beta function. That is, we will use this form, that is 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta dot d theta. ओके, तो जब हमने ये प्रॉपर्टी देखी थी बीटा फंक्शन की, तो इस वाली प्रॉपर्टी को हम यूज करने वाले हैं यहाँ। तो भाई इस बार भी हम एम एन एन को 1/2 के इक्वल रखेंगे। ओके, तो हमें क्या मिलेगा, द वैल्यू ऑफ बीटा 1/2 and 1/2 will be twice of 0 to pi by 2 here sin 2m minus 1, that is 2 upon 2 minus 1, that is 0 dot theta, and the same for cos, so cos 0 not theta 0 theta d theta. Okay, now we will get 2 0 to pi by 2. Now this will be 1 and this will be 1 because pi is 0. Okay, so we will get d theta only. Now we will solve this. So 2 theta 0 to pi by 2. Okay, now what we will get, 2 pi by 2 minus 0. So therefore we will be getting this answer. So now what is left side, beta 1/2 comma 1/2 will be pi. Now this is equation third. Now what was our equation second, that is the value of this is equation second. Okay, that is the value of b 1/2 comma 1/2 equal the whole square of gamma 1/2.
क्योंकि गामा 1 की वैल्यू तो 1 होती है, हम जानते ही हैं, तो हम कह सकते हैं कि
second and third we can write that the this value, the value of the second equation is the square of gamma function, gamma 1/2. Now we will get the value of pi. Okay, so from both these equations we can say that the value of gamma 1/2 will be root pi. Okay, so this was our required proof, and इसके बाद हम देखेंगे अगली वीडियो में गामा फॉर्मूला। तब तक के लिए थैंक यू, वेलकम। आज की इस वीडियो में हम हमारे समाकलन गणित की सीरीज को आगे बढ़ाते हुए देखने वाले हैं लीजेंडर्स डुप्लीकेशन फॉर्मूला। पिछली वीडियोस में हम बीटा गामा फंक्शन की कई सारी प्रॉपर्टीज देख चुके हैं, ठीक है। तो आज हम देखने वाले लीजेंडर्स डुप्लीकेशन फॉर्मूला। सबसे पहले देखते हैं लीजेंडर्स डुप्लीकेशन फॉर्मूला होता क्या है, उसके बाद हम इसे प्रूव करेंगे, ठीक है। तो ये होता है गामा एम इंटू गामा एम प्लस 1/2 इक्वल होता है रूट पाई 1 2 to the power 2m minus 1 into gamma 2m, where m belongs to integers. So this is our Legendre's duplication formula. इसको हम बीटा गामा फंक्शन के बीच में जो रिलेशन होता है उसमें मदद से प्रूव करते हैं। तो सबसे पहले देखते हैं बीटा गामा फंक्शन का रिलेशन होता क्या है। ओके, तो बीटा mn इक्वल गामा m इंटू गामा n अपन गामा m प्लस n। सो इस रिलेशन की मदद से हम जो है इस लीजेंडर्स डुप्लीकेशन फॉर्मूला को प्रूव करने वाले हैं। इसका प्रूफ हम देख चुके हैं वीडियो में, ठीक है। तो सबसे पहले हम सपोज दिस इक्वेशन 1, तो लेट n equal 1/2 in equation first. Okay, so what we will get, beta m comma 1/2 will be gamma m into gamma 1/2 upon gamma m plus 1/2. Okay, and we will use here the property of gamma function, that is we can write the gamma function as integration 0 to pi by 2 price of, and what is this value, we will get sin to the power 2m minus 1 theta, 2m minus 1 theta into cos to the power 2n minus 1 theta, and what is n, 1/2 minus 1 theta dot d theta. Here m into gamma 1/2 upon gamma m plus 1/2. Now we will further solve it, so we will get price of 0 to pi by 2 sin to the power 2m minus 1 theta dot this will be 1 minus 0, this will be 1. Okay, so d theta. Now gamma m, and what is the value of gamma 1/2, that is 2 pi. We have also proved this property in recent videos, so you can see the proof at 1/2. Okay, so what we can say that the value of 0 to pi by 2 sin to the power 2m minus 1 theta dot d theta will be equal to gamma m into 2 pi upon 2 into gamma m plus 1/2. So what is our equation second? Okay, now we will put the value of m equal n. Okay, or we can say the value of n equal m in equation first. Okay, now we will put the value of n as m, that is we will solve both the m and n as the m. Okay, so let's beta mn will be 0 to, sorry, here we will use the property in the next step. So what is the function of gamma function? Okay, so we can write gamma m into gamma m because m is also n, the value of n is also m here. Okay, I hope you understand. We have simply put the value of n as m. So here n will be m and gamma m plus n. Okay, and what is the value of n? We have put m as, so we can write it as the value of square upon here what we get 2m. Okay, now we'll move ahead. So now we will use the property of beta function here again. So price of 0 to pi by 2 integration sin to the power 2m minus 1 theta cos to the power 2m minus 1 theta, because n is also m here. Okay, so this was m, not n. I hope you understand. Now d theta will be equal to square upon gamma 2m. Okay, so now what we can write here as 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2m minus 1 theta, d theta will be equal to whole square of gamma n upon gamma 2m. Okay, now we will use the property of sin to theta. So if I write, suppose this is sin theta into cos theta. Okay, so let's put the power common. So I can write sin theta dot cos theta to the power 2m minus 1 theta, 2m minus 1. Okay, 2m theta and d theta, because we can because the power is same, so we can take the power common. And here whole square of gamma m and 2 gamma n with gamma 2 n. Now we will further simplify this. So if I put 2 sin theta cos theta, that will be sin 2 theta. Okay, so I will multiply with 2. Okay, and also I have to divide with 2. So to the power 2n minus 1. Here we will get 2 sin theta cos theta d theta, and the power is 2n minus 1. Here the square of gamma n upon gamma 2m. Okay, so what I can write 1 upon 2 to the power 2n minus 1 will be equal to sin 2 theta dot d, and here the sign of integration. Okay, now 0 to pi by 2, and here the same value gamma 2m. Okay, so we have focused something that there was 2 na, this 2 is missing, so this was a numerator 2 and 1 into 2 the power, and this is 2. Now okay, so now we will further solve. So 2 to the power 2m minus 1 equals, now we will solve this function. Let's suppose here 2 theta as t, and what can we write? D theta will be t by dt by d theta will be dt by 2. Okay, and limit will be 0 to pi, as you can see. When theta is 0, t is 0. Okay, but when theta is pi by 2, then t will be pi. Okay, so here I can write 2 to the power 2n minus 1 into 0 to pi sine, and also the power is 2n minus 1, and here sine t to the power 2n minus 1 dot dt by 2, and here same square upon gamma 2m. Okay, so what we can write here, I can write this 2 out of this integration, so this 2 will cancel out this 2, so 1 upon 2 to the power 2n minus 1, and this will be 0 to not pi by 2, this is limit has been changed to be only pi. Okay, so 0 to pi sine 2n minus 1 t dt will be equal to gamma 1 whole square and gamma 2m. Okay, so I hope you understand here what we have done. Now we will further solve this equation. Now we will use the property of integration. So suppose this is 2 to the power 2m minus 1. Now we will break this limit into two intervals. Okay, so if I because this is a symmetric function, so the value of 0 to pi by 2 will be equal to pi by 2 to pi. Okay, I hope you know the basic values of integration. So if I write twice of 0 to pi by 2, and the function will be same, so 2m minus 1 t dot dt, then this will be the same value of this, because we have break the limit into two intervals. Okay, sorry, this is integration. Now here we have the same value gamma m over square gamma 2m. Now okay, so we can say that the value of 0 to pi by 2 sine to the power 2m minus 1. Now we can change this t as theta, because the variable is same and dt. Okay, so if we put t equal theta, there will be no change in neither in the function nor in the limit, because if you put t equal 0, then theta will be 0, and if you put t equal pi by 2, theta will also be pi by 2. Okay, so this is also a basic property of integration. You can change the variable all along. Okay, if it does not change the limit. Okay, so theta dot d theta, and 2 gamma 2m. Now suppose this is our equation third. Okay, so what was our equation second? Our equation second was, this was our equation second. Okay, so see carefully, we have got the same term in the equation third, so we will put these both equation as equal. So we will get here gamma m into root pi upon 2 gamma m plus 1 by 2. Okay, so I can say that the value of, okay, you see the value in left side both are same, so I can write the value of from equations second and third. What we can say, we can write that the value of gamma m into root pi upon the value of what we got here, 2 gamma m plus 1 by 2. 2 gamma m plus 1 by 2 will be equal to here gamma m whole square and 2 gamma 2m. Now we will solve this. So this will be cancelled out with 1, and 2 will be cancelled out from 2. Now we have mistaken something, we have forgot this term. Okay, so this will be here. Okay, let me write this term into, we have to do this term, so 2 to the power 2m minus 1. Okay, so 2 to the power 2m minus 1 here. Now what we get, root pi upon gamma m plus 1 by 2 equal gamma m upon gamma 2m 2 to the power 2m minus 1. Now we have got the required Legendre's duplication formula. We will arrange this in the same manner as we have told earlier. So now what we have seen, we will see that gamma m here and we will multiply here. So gamma m plus 1 by 2, what we will get, root pi into gamma 2m upon here 2 to the power 2m minus 1. Okay, so let's further rewrite it. So gamma m into gamma m plus 1 by 2 will be equal to root pi upon 2 to the power 2m minus 1 into gamma 2m, and this was our required Legendre's duplication formula. Okay, you forget something, the m, gamma m. Okay, here gamma m also remaining, so gamma m, this is gamma m, and this was our required Legendre's duplication formula. Okay, so now we will meet in the next video with some other properties of beta and gamma function. After that we will solve some questions. Okay, until then, thank you. अब हम बीटा एंड गामा फंक्शन की एक प्रॉपर्टी को देखने वाले हैं, ठीक है। बीटा एम एन इज इक्वल टू बीटा एम प्लस 1 कोमा एन प्लस बीटा एम कोमा एन प्लस 1। ओके, तो इस प्रॉपर्टी को प्रूव करने के लिए हम बीटा एंड गामा फंक्शन के बीच में जो रिलेशन है उसे यूज करने वाले हैं। ओके, so what is the relation between beta and gamma function? Beta mn is equal gamma m into gamma n upon gamma m plus n. Now this is equation first. Okay, so now we will put we'll substitute n as, let's m first. So we will substitute m as m plus 1. Okay, and in the second equation we will substitute n as n plus 1. So what we will get, if we use this condition, then we will get the beta m plus 1 comma n, and here beta m comma n plus 1. Okay, and what will the value of these two terms, beta m plus 1 comma n, will be gamma m plus 1. Okay, because we have put the value of m as m plus 1 and gamma n will be same. Here gamma m plus 1 plus n. Suppose this is equation second, and now what will be the equation third? We will put n plus 1 at the place of n. Okay, so beta m comma n plus 1 will be gamma m into gamma n plus 1 upon gamma m plus n plus 1. Okay, equation third. Now we will add equation second and third. Okay, so by adding equation second and third we will get, okay, so we will get the value of beta m plus 1 comma n plus beta m comma n plus 1 as gamma m plus 1, okay, into gamma n upon gamma m plus n plus 1, and here plus gamma m into gamma n plus 1 upon gamma m plus n plus 1. Okay, now you know the value that एक प्रॉपर्टी हमने देखी थी ना, the value of n plus 1, gamma n plus 1 will be as n gamma n. Okay, and we have also proved these properties where when we saw the recurrence formula of gamma function. Okay, so we will use this property in these two functions, so that we can write here m gamma m into gamma n as it is, plus gamma m plus n plus 1, and here m into n gamma n. Okay, gamma m plus n plus 1. Now we will use this property also in the denominator. So what we can write, m gamma m upon gamma n upon, here we can write m plus n as a single function, and here m plus n. Okay, we have used this same property here, so there is nothing to be result of. Now here m, sorry, n gamma n gamma n upon m plus n gamma m plus n. Now we will that's common, so m plus n gamma m plus n. Here we will get the same, so m gamma m into gamma n plus n gamma m into gamma n. Now we will simplify this and we will get our answer. So here the common is gamma m into gamma n, and what is m plus n, and in denominator m plus n into gamma m plus n. So what we will get? We will get the value of gamma m into gamma n upon this will be cancelled out, so m plus n. And what is this function? This is beta mn. Okay, and what is in the left side? Beta m plus 1 comma n plus b m comma n plus 1, and we have got this answer as beta mn, and this was the required proof that we have uh, to prove. Okay, so now let's move ahead for the next property.